Okay, so we've talked through the ordered pairs, showing you how they are inverses of each other, showing you how their ordered pairs have flip-flopped. Here's a graph with both of them on the same graph, showing you that that exponential and that logarithmic function are inverses of each other. Now, let's talk about the domain and the range of each one and the asymptotes, the y-intercepts, and the end-behavior. All right, the domain on a logarithmic function. Well, here's the logarithmic function. Remember, it goes to negative infinity. But as x approaches negative infinity, what's that y value? Does this keep going out forever? It does keep going out to negative infinity, and it does keep going up and out forever to positive infinity. So the domain of an exponential function is all real numbers, negative infinity to positive infinity. Keep in mind that the domain of a function and the range of its inverse should be the same thing. So while we're talking there, let's come over here and talk about the range of this inverse function. Range, remember, is from down to up. Remember, this graph goes down forever right beside that x-axis. And it starts down, it curves up, and it goes out forever. It goes up and out forever. So the range from down to up is all real numbers. So the domain of... Sorry, my light went out. All right, so the domain of an exponential, the range of the logarithmic are going to be the same. Now let's talk about the range of the exponential. All right, remember the range value. Remember up here when we were talking, up here on the graph, that y value will never get to 0. It'll get close, 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 but won't get there. Will never equal 0. That y value will never be 0. So that lowest y value is going to be 0. Does not include 0. And then it goes up forever to positive infinity. So the range is 0 to positive infinity. Remember, the range of a function and the domain of its inverse should be the same exact thing. So let's go over and talk about the domain of the logarithmic function. The domain, remember, is the x value. Now, the domain, this graph comes down and it goes down forever, but it never goes any further than x equals 0. It actually never even gets to x equals 0. So right there, that shows the domain. The domain, the lowest x value that you can get is as close to 0 as you can get, but not actually being 0. So the domain here is from 0, not included, and then it goes up forever, out forever. The out forever part of it is the domain. So on an exponential, the domain is all real numbers from negative infinity up and out to positive infinity. There's the domain. The range, the lowest y value is 0 up to positive infinity. On a logarithmic function, the domain, pay attention, it curves down. It never hits that. It never goes past x equals 0. It never even gets there. So the domain is 0 not included to positive infinity. The range is forever down there to up and out. The up part of it is positive infinity. That's the range. So the range is from negative infinity to positive infinity. Now, keeping those limitations in your mind, let's talk about the asymptotes. Remember, the asymptote is the line that graph approaches but never gets there. Well, on the exponential, as x approaches negative infinity, your y value gets close, close, close to 0 but never gets there. That horizontal line, y equals 0, is your horizontal asymptote, y equals 0. Now, look at the asymptote for the logarithmic function. Well, keep in mind, remember, your graph comes down right beside that x-axis but never goes across it. So there's a vertical asymptote on the line x equals 0. That graph is never going to touch x equals 0. Remember we talking about we never got an x value to be 0 a while ago? So I have a vertical asymptote on a logarithmic function. The vertical asymptote x equals 0. This is a horizontal line, y equals 0. This is a vertical line, x equals 0. Very important that you remember that one is a horizontal asymptote, so you have to write that horizontal line equation, y equals 0. Vertical equation, x equals 0 for that vertical asymptote. The y-intercept, you're going to be able to find that y-intercept. The y-intercept of a exponential function where that graph crosses that y-axis. Remember, it's going to cross it at up 1 over 0 up 1 when that x value is 0. Anything raised to the 0 power is 1, so 0, 1. The x-intercept is over 1 up 0. Over 1 up 0. Well, let's go plug x in. Log base 2 of 1. Well, that says 2 to the what is equal to a 1. 2 to the 0 is equal to 1. So that ordered pair, 1, 0, is the x-intercept. Noticing your logarithmic function never crosses that y-axis, so there is no y-intercept. Same thing for your exponential function, never crossing the x-axis, so there is no x-intercept. Now that's on the original. What we're going to do on block day is we're going to talk about the translations and the reflections. Then you may have an x or y-intercept, but we're going to worry, this right here is what we're going to worry about. Now, let's talk in behavior. The in behavior of your exponential function, we're talking as x approaches something, as far left as we can go and as far right as we can go. So, as x approaches, let's go left. Does x approach negative infinity in an exponential function? It does. As x approaches negative infinity, what does f of x approach? As x approaches negative infinity, f of x approaches that asymptote. So f of x approaches 0. As x approaches negative infinity, your y value gets close to 0, but never gets there. So as x approaches negative infinity, f of x approaches 0. As x approaches positive infinity, y value goes up forever. So as x approaches positive infinity, f of x approaches positive infinity. So as x approaches negative infinity, f of x approaches 0. As x approaches positive infinity, f of x approaches positive infinity. On the in behavior of a logarithmic function, be careful what you write right here. We're used to writing as x approaches negative infinity, but does x approach negative infinity? No, it doesn't. X never goes across x equals 0. So here you're going to have to say as x approaches 0, what does f of x do? As x approaches 0, f of x approaches negative infinity. So remember, in a logarithmic function, x is not approaching negative infinity on the original. Now, you may have a reflection in your in behavior change, but on the original logarithmic parent function, x is going to be approaching 0, f of x is going to be approaching negative infinity. And then go the other way. As x approaches, yes, it does approach positive infinity. As x approaches positive infinity, f of x also approaches positive infinity. So there's all of your in behavior, your asymptotes, your x and y intercepts, your domain and range of an exponential and a logarithmic function. When you come to class on block day, we're going to talk about transformations. We're going to talk about shifting left, right, up and down. So keep in mind that on an exponential function, the domain is always going to be all real numbers. The range will be affected, okay? The range can be affected if you have a translation, okay? The range will be affected by a vertical. The range will be affected by a vertical translation or reflection. Now, what do I mean by that? I mean shifting up or down, or reflecting vertically, meaning reflecting across that x-axis, your graph turning upside down, okay? Your asymptote on your exponential will also be affected by a vertical translation. You need to keep that in mind. That means moving up or down. A horizontal shift, keep in mind that domain is always all real numbers. So a horizontal shift is not going to do anything to the domain or the range. A vertical shift or translation reflection is going to change the range and the asymptote possibly. Okay? So here we have f of x equals a times b raised to the x plus c plus d power. This a, that multiplies, remember, that could be a negative sign. That makes you reflect across the x-axis. And this number hanging out here, those are outside the function. Those are outside the function. That is going to affect vertical. That affects vertical. Okay? That affects vertical. Now look right here inside. Look where the inside is. Inside the function is up in that exponent. Up in that exponent. That affects horizontal. So there's what that graph may look like. This, you may see a translation. If you see a plus or minus up in that exponent, it's going to shift you horizontally. If you see a plus or minus number at the end, it's going to affect you vertically. Now, on the logarithmic function, the range is always going to be all real numbers, okay? The range is not going to be affected at all. It's going to be all real numbers. It doesn't matter if you shift up or down. If you shift left or right, that range is still going to be all real numbers. The domain, however, all this information is going to flip-flop. The domain will be affected. The domain will be affected by a horizontal. By a horizontal translation or reflection. I'm trying to be quick. I'm running out of time on my video. It can only video for 15 minutes, and I'm at 11:38 right now. So, domain will be affected by a horizontal translation or reflection. The asymptote here, not vertically. Remember, this vertical, doesn't matter how you move up or down. If I move left or right, okay, the asymptote will be affected by a horizontal translation. And this is if you're talking, here I'm talking about a logarithmic function, okay? So that vertical asymptote is going to be affected by a horizontal translation. Now, this equation, translated, may say f of x equals a times log base b of, and you have parentheses, x plus c plus d. And again, it's the same thing. That a and that d affect outside. That's going to shift you. That's going to do something vertically. That's outside the function. That is doing it vertically. That's moving you up and down. Well, guess what? Vertical does not affect anything because the range can't be affected here. It's all real numbers, and vertical doesn't change the domain. This right here, this inside is what's going to affect your domain. If something happens inside that function that's doing it horizontally, that's going to affect your domain. And the domain can be affected here, okay? So, be ready to translate, reflect, and tell the domain range, the asymptotes, the end behavior, the y-intercept, and the x-intercepts on Tuesday.